Good evening, everyone. Can you hear me adequately? Very good. Very good. Before I begin, there are just a couple of announcements that I would like to make. First of all, I'd like to introduce our son and daughter-in-law, son Tim and daughter-in-law Elaine. They're back. Tim is currently teaching astronomy down at Elon College. So, in fact, when he was an infant, we stuck him to bed more than once in the observatory floor at the San Diego State Observatory. So, in a sense, he didn't have a chance. And of course, my wife Ruth, that was here last week as well. I would also like to make another announcement. On September 22nd, that's a little ways out yet, there is an astronomy day at Guilford Technical Community College. And this year's speaker is Dr. Roger Windhorst from Arizona State University. And his topic on Friday evening is the world of Webb and seeing through the eyes of Einstein. Now, let me tell you a little bit about Astronomy Day, and I think there may be a bus going from here down to Guilford Tech for the Astronomy Day lecture. The Friday night presentation, we always tell our speakers, now listen, this is an evening where you're supposed to speak to the general public. You're not supposed to give a technical lecture, so it is supposed to be for everybody to understand. And generally, the speakers have done pretty well on that score. But if you have any interest in that, stick it on your calendar. It's a Friday evening. And also, one other question of curiosity. I've spoken with Tom English, who has taken my place at Guilford Tech. And I've spoken to him about the possibility of taking a group from Friends' Homes down to the Guilford Tech GTCC Observatory. It's a 24-inch telescope, one of the finest open to the public. Now, how accessible is it? There's about 10 steps, 8 or 10. So, unfortunately, it's not on one floor, so you have to go up a little bit. But I'm curious, this is not a commitment, but I'm curious how many of you might be interested in a night at the observatory? Just raise your hand. Okay, all right. Yeah, well, I'll talk to Tom. It won't be before October. And that's just as well, because sunset will be happening much earlier by then, and we can arrange transportation or whatever. But the observatory probably has more visitors than any of the other. It's one of the better observatories open to the public in the multi-state region. So, yeah, and Jupiter and Saturn will be in good viewing position then. We'll pick out some good stuff. Alrighty. Again, if you have questions at any point throughout the presentation, don't hesitate to interrupt and ask me. So tonight I want to take you through the solar system. So what's present? Now remember, in the solar system, there were 7 planets early on. The sun, oh wait a minute. Remember, the planet is the moving body. And the moving bodies were the sun, the moon, Mercury, Venus, not the Earth, Mars, Jupiter, and Saturn. So there were 7 bodies. That was the early history. So what do we say today? Well, I would contend, I can argue for 2 planets in the solar system. I can argue for 4. And those are shown to scale size. I can argue for 8. I'll never argue for 9. Now, if you wish, there can be a lot more. But as you see, there is a difference. And if you were an extraterrestrial visiting the solar system, coming in, you might notice 2 planets. That might be what you would see. So let's take a look at the 8 bodies and a bit more trash, but we'll get to that later. These little dots down here, those 4 are the terrestrial planets. And there they are again, shown to scale with respect to each other. Mercury, Venus, Earth, Mars. These are the 4 rocky bodies. Oh, there's some rocky material in the others as well, but these are predominantly rocky bodies. So let's take a brief look at each one. First of all, the planet Mercury. Closest to the sun, very slow rotator, the only one with effectively no atmosphere. Oh, there's a little bit of gas there, but how much gas does a planet have to have an atmosphere? So I would say, probably not. I would be inclined not to call it an atmosphere. So what's nice sunny day like on Mercury? You don't want to be out in the sun. It's only 4/10 of an astronomical unit from the sun, so it gets a little on the warm side. In fact, the middle of the Mercurian day, the temperature can get up as hot as about 800 degrees Fahrenheit. Hot enough to melt lead. But in the Mercurian night, and by the way, Mercury is a very slow rotator, in the Mercurian night, the temperature drops several hundred degrees below 0. There's a 1,000-degree difference between daytime and nighttime. So it's not exactly, not a place that I have much inclination to go visit. Superficially, Mercury looks like the moon, but I'll get back to that a little bit more later. So just how big is Mercury? Well, a number of years ago, Mercury transited across the sun, and there's the little spot of Mercury against the sun in the background. So it's quite tiny. That's an image that I took at the Klein Observatory. And by the way, if you want to see Mercury, one of the easiest times to do is to look at it in the daytime, because it is never far from the sun, only about 4/10 of an astronomical unit is the distance from the Earth to the sun. And being only 4/10 of an astronomical unit away, it orbits the sun quite rapidly, and as I said, being that close, it gets very, very hot. And the reason for looking at it in the daytime is because it's so close to the sun, If you wait till the sun goes down, Mercury is already close to the horizon. So it's easier to look at it when it's high in the sky, and that's the reason why with proper alignment you can see it better in the daytime than you can in the evening. As I said, superficially it looks like the moon, but there's a difference. The craters and the mountains are not nearly as rigid and tall. The stronger gravitational field has flattened things out more. So, but you do see lots of craters and a lot of features that look quite a bit like the moon. That is a color image of the moon. You can only see of Mercury. You can see only, well, here you can see only slight variations. And again, you see the craters, the mountains, valleys, and so on. Has a magnetic field, and density is comparable to that of the Earth. Next, we move out to Venus. These are again images that I took at the Klein Observatory. Venus goes through phases just like the moon. When it's on practically the opposite side of the sun, you see almost a complete sphere. Then it goes through gibbous, quarter, and crescent phase. Right now, Venus is in the morning sky in the crescent phase. If you feel like getting up really early and looking, you might be able to find it. There's too many trees around here. I won't even, and lights, I won't even try it. These are probably, this is, if you look through a large telescope, this might be about what you see, exaggerating the features. There's a little bit of a cloud pattern to it, but Venus is almost featureless. In fact, when you look at it through a telescope, you really don't see features because it's constantly cloud cover. And it is a slow rotator. Now, Venus is supposed to be the goddess of love. And all I can say is that if Venus is the goddess of love, she's one hot baby. Because the temperature on Venus is actually hotter than it is on Mercury. So why is it so hot? Have you ever heard of the greenhouse effect? Well, Venus has the runaway greenhouse effect. It has an incredible atmosphere, many times the density of the atmosphere on the Earth. A slow rotator, but because of the dense atmosphere, there are strong winds, and the temperature on the nighttime side and the daytime side are just about the same. So, not a very attractive feature in that regard. Again, here is Venus in a solar transit, and if you want to see one, well, I'm sorry, you're not going to. They happen in two, I think it's 12-year succession, but then they don't happen for a long time in between. And the two times have already passed. And I'm going to tell you, you and I are not going to live long enough to see another transit. But compared to it, you can see that Venus is significantly larger than Mercury. In fact, Venus is almost the twin of the Earth in size and mass. Just a little bit smaller than the Earth and just a little bit less mass. But there are other features about Venus as well. The cloud cover. It is so thick that we can't see it. Some other infrared radiation can penetrate it, but There are clouds, but you don't want to get caught on a rainstorm. Why? Well, because there's enough material in the atmosphere that if you get caught in a rainstorm, it might be a sulfuric acid rain. That's battery acid. And if you get caught, it might dissolve your umbrella and then start in on you. So, and again, the temperature being so hot, you don't want to be there day or night. This is probably a little bit of an exaggeration, but the temperature is so close to 1,000 degrees that I suspect if you were standing on the surface of Venus, it would be just at the barely red hot phase. That's how hot the surface is. And there are some interesting features. There has now been confirmation. It was suspected for quite some time, but there's now confirmation that there are active volcanoes on Venus. So it is volcanically active. There are some impact craters, but all the impact craters you'll notice are very large. Now, why do you think they're so large? Well, remember, impact craters happen when an asteroid or a large meteor comes through the atmosphere and plows into the surface. But because of the thickness of the atmosphere, the smaller meteors are burnt up, so you don't have large impact craters. But here is a volcano. I'm not sure that that one necessarily is active. I forget which feature is the active one. But it has been they thought for quite some time that it probably had activity, and with radar penetration and some other features, it has now been confirmed. So they've also discovered some changes in the gas, which is characteristic of volcanic activity. Venus has not had as many probes as we may wish. In fact, there's some consideration that there may be some new probes sent to study Venus more carefully, so there's a lot we still need to know. There's only one probe ever been sent. The Soviet Union, years ago, when it still was, I'm pretty sure it was when it was still the Soviet Union, sent a lander on Venus going down through the dense atmosphere. It successfully landed on the surface, but of course if the temperature is up around 1,000 degrees, your instruments aren't going to last that long. They only had a few minutes, but they did take a few pictures. And as you can see, a rocky surface. These are simply part of the Venera lander, and here again is another. And the yellowish color is probably fairly accurate because of the filtration through the dense clouds. And you can see there's a lot of rocks and so on the surface. So in some ways, Venus is our twin. Thank goodness we're not like Venus. Leaving our second planet, we move on to terra firma, home sweet home. And that does look rather beautiful, as you can see from the satellite view of the United States and cloud cover. It's kind of interesting to see what people had as the impression of the appearance of what it would look like from the satellite before satellites were there. It's much more attractive in the reality than what was projected. Hurricane Florence, some of you may remember that, back in 2018. Very strong swirl, the eye of the storm. That hurricane, as I recall, hit North Carolina pretty hard. There's the Antarctic ice cap. It would be interesting to see a current map of that, because I'm sure the ice sheets are not as large as they had been. So I suspect that considerably different. There's the very famous Earthrise over the moon. I forget which Apollo mission it was that took that picture, but it's a very famous picture. Here's the moon and the Earth. A very beautiful sight. Here's an interesting comparison. This is the moon and the Earth and shows the comparative size. Now, one of the things that's very fascinating is that our moon, compared to the size of the parent planet, is basically the largest of any in the solar system, with the possible exception of Pluto and Charon. But the moon is in fact, a significant body in the solar system. And in fact, there is some evidence that the moon may be a critical factor for life on the Earth. Now you say, what in the world does the moon have to do with life on the Earth? Well, the evidence is pretty strong that life on the Earth required a very stable environment. And the moon in its orbit has probably helped stabilize the Earth's position, keeping us from getting too close or too far away. If we were a lot closer to the sun, we'd be too hot. If we were much further away, we'd be too cold. So, as I said, there's still ongoing work on this, but it may be that the moon is a stabilizing factor. And again, these pictures are not quite, they've been enhanced a bit because the moon is much darker compared to, the Earth reflects about roughly 30% of the sunlight falling on it. The moon reflects only about 10%. So really, to show this more accurately, either the Earth should be much brighter or the moon should be much fainter. One of the two. And what would we look like from 3.75 billion miles away? There, that's the Earth. The Voyager satellite, looking back from way out in the solar system, looked back and saw the pale blue dot. Ladies and gentlemen, that's home sweet home. That little tiny dot. That's it. That's us. Pretty amazing. Leaving home sweet home. Going out is the planet Mars. Now, if you want to go visit someplace, my recommendation, if you want to visit another planet, my recommendation is Mars. So am I a candidate to go out there? Well, I tell you, you give me a chance to go to the moon, I'll be ready to pack up and go tomorrow. You give me a chance to go to Mars? No, I'm not so sure about it. Why? Well, you want to take a rush trip to Mars? Okay, it'll take you about 7 months. So who would you like to be cooped up with in a small spacecraft for 7 months? Now, I appreciate Ruth a great deal, but I would prefer not being cooped up in a room much, much smaller than this without any place to go for 7 months. Okay, so you get to move.
And neither would I.
So you take your trip to Mars, take 7 months, and you spend a couple weeks there or a month or two and say, okay, fine. I've now seen what I want to see here in Mars, and you decide you want to take off and come home. But there's a problem. If after a couple of months you decide to go home, you come back to the Earth's orbit, but Mother Earth won't be there. So you have to wait. So a rush round trip to Mars is roughly 2 years in length. And what are you going to live on for those 2 years? I know there's that film that came out on, I forget what it was called, Lost on Mars or whatever. My son showed it to me, older son. Some people got really liked the film. I thought they made too many assumptions and I was unimpressed. But anyway. And if you ever see Mars like that through a telescope, you've got a good view. So what's it look like ordinarily? A little orange dot. And that was unusual. But you can see a few features on the planet. Here are Hubble Space Telescope views, and you notice there's a big difference, but it's the same region, so what's the difference? Well, here was June to September. Every now and then, Mars kicks up a dust storm. Mars is a very dusty planet. And not only is it a dust storm, but it can basically cover the whole planet. Now, we have dust storms here on the Earth, but nothing like that. The atmosphere is much thinner than here on the Earth, but the thin atmosphere does kick up some very strong winds. There are the polar caps. When Mars is closest to us, we can see some of the polar caps. So what are they like? Well, here's the North Pole, the South Pole. So what is the ice? It's mainly dry ice, frozen carbon dioxide. And underneath the dry ice, there's water ice. So water has been confirmed on Mars. So if we go to Mars, there will be access to water. And that's significant because you need some water. And also you can break the water molecule apart and make rocket fuel out of it. Because if you break it apart, and you can do that with solar radiation, you would have oxygen and hydrogen. The hydrogen would make the great fuel, and the oxygen, of course, would be needed for the oxidizer. These polar caps pretty well disappear in the Martian summer. The dry ice completely disappears. The water ice is probably underneath still there. The surface, you like mountain climbing? There is the largest volcano in the solar system. That is about the size of the state of Arizona, about 3 times taller than Mount Everest. The caldera at the top is about 50 miles across. That's a big one. It is no sign of current volcanic activity, but it has been probably not too long in the geologic past. As I said, that's the largest volcano known anywhere in the solar system. I thought this was a photograph, but I found out today that it was not. That was a painting based on somebody's ideas of Olympus Mons, where they thought there was frost and clouds, and there is some frost and clouds, but you'll probably never see anything like that. And this is a truer color. So what's the surface like? While I wouldn't want to visit, I am glad that a lot of probes have been sent. In fact, my opinion is send probes, don't bother sending people. Probes don't mind if they don't get a shower, if they miss a hamburger every now and then, and they don't care if they don't come back. So dollar-wise, to me it makes a lot more sense to send a laboratory to Mars rather than bothering to send people. Now, I know a lot of people want to go there, and it may happen. I doubt that I'll live to see it. This was what the Viking lander saw in 1976. Very rocky, almost like a desert environment. Pathfinder, little tiny, little bitty thing. And there's another lander. Much larger landers have been sent more recently. Oh, what's that look like? Well, that looks like a dry riverbed. So guess what it is? It probably is a dry riverbed. That indicates that there must have been liquid water at least in some time. And if you look carefully, that looks like stratified layers. There is compelling evidence, very strong evidence, that Mars had a lot of liquid water in the past. There may not be any liquid water there today. If there is, it's probably buried under the surface, because the atmosphere is so thin that any water on the surface would boil away. And here is more recent probe. You've heard about the little helicopter on Mars. It was sent there to test to see whether it would work. It has worked spectacularly. I think they were planning for 9 flights, if I'm not mistaken. They've gone 20? 50, okay. I didn't check the actual number, but it's still working. And so it suggests that a good way to explore Mars might be to send some more flying craft that can go around, cover much more territory. Day on Mars is almost the same as ours. Instead of a 24-hour, it's a 24.5-hour. About 1.5 times the distance that we are from the Sun. And Mars has 2 moons, Deimos and Phobos, but you notice the size, that's 5 kilometers, about 3 miles. So this thing, possibly 20 miles across, but not very large. And there's some strange striations on it. It's probably not a stable orbit, so eventually these moons may crash into Mars. Be interesting to see that happen, but won't happen in our lifetime. So much for the terrestrial planets. So then we move on to the Jovian planets. And you recall from the first slide how much larger the Jovian planets are than the terrestrial ones. First of all, Jupiter, the giant of them all. About 11 times the diameter of the Earth. Okay, if it's about 11 times the diameter, that means if you hollowed it out, more than 1,000 Earths would fit inside Jupiter. So it is the granddaddy of them all. So it ought to weigh 1,000 times what the Earth does, right? But it doesn't. It only weighs about 318 times what the Earth weighs. So what does that tell you about the composition? It's got to be lighter stuff. And this is about as good a view as we get at the Klein Observatory. Hopefully it may happen. Back in 2020, in our backyard, Saturn and Jupiter were very close together. There was Jupiter with a couple of its moons, and there's Saturn. They were less than a moon's diameter apart. Kind of a beautiful sight. So let's take a little more look at Jupiter in detail. Very stormy. In fact, you can see these big cloud bands. If we have a clear night when we go down to the Klein Observatory, you'll be able to see some of those. And what's that? That's a big storm. Oh, but if it's 11 times across, that storm is about the size of the Earth or larger. And how long has it been going? Galileo saw the thing and it's been going ever since. So it's at least 300 years. How would you like a hurricane to last 300 years? It's an incredible storm. Varies a bit in color and also a bit in size, but it's been going on for a long time. Here's the big red spot. There's big white spots. That's about the size of the Earth. Very complex patterns. And what's that? I don't know if you like thunder. How many of you like thunderstorms? Okay, a few of you. I love them. But I'm telling you, a thunderstorm on Jupiter is something else. Jupiter's lightning strikes are many times more powerful than the ones here. In fact, most of the planets that have atmospheres, which happens to be most, probably do get some thunderstorms. And there's an example where we caught the lightning in progress. Moons, and we'll come back to moons. By the way, Jupiter may be about as large as a planet can ever get. Why? Well, let's stop and think. We know that since it's only over 1,000 Earths would fit inside, but only 318 times the mass, it must be made out of lighter stuff. Now, to understand what's going on here, imagine a large silo or some large vertical room, and you dumped either marshmallows or the softest bread that you can get, plain white bread that has no texture to it whatsoever, but just mushy stuff that you can squeeze down. Suppose you filled the silo half full. If you dumped in the same amount again, would the silo be full? What do you think? Why not? Because the weight of the material on top would squish it down. Now, that's exactly right, because as you pile more stuff on top, instead of going up, you're going to squish it down a lot. And I don't care what material you have, material is compressible. And we know that Jupiter is predominantly hydrogen and helium, and if you would try to add more stuff on top, instead of making it bigger, the additional gravitational field and the weight on the top would squish it down and compress it to the point where eventually it would start getting smaller again. So as I said, Jupiter is probably about as large as a planet can get. In fact, much of the material, while much is hydrogen, the hydrogen is compressed so tightly that it converts the hydrogen into a liquid metallic form, which gives it a very strong magnetic field, but a very powerful magnetic field as well. And Jupiter and some of the other planets have aurora. We have the northern and southern lights. A number of the planets have those as well. Okay, what about the moons? Galileo discovered 4 moons. Callisto is the furthest out of the ones he found. It's a bit larger than ours. I think it's the 3rd largest moon in the solar system. Lots of impact craters, probably heavily ice on the surface. Moving in is Ganymede, the largest moon in the solar system. I believe larger than the planet of Mercury. And their impact craters, something must have broken apart and you had a whole string of impacts at that point. Again, a lot of ice. There is Europa. Now look carefully. How many impact craters do you see? There's the little square and it's blown up. What do you notice about impact craters? Not much. What does that imply about the age of the surface? It must be a very young surface. And there are cracks, and we now conclude that there's ice, and those are cracks that probably filled in. In fact, Europa probably has more ocean than we have here in the Earth. Frozen on the surface, but underneath it's warm enough to keep it in the liquid phase. In fact, there's a lot of people who would like to go to Europa to check to see whether there's any chance of any life there. There are some eruptions occasionally, but it's an interesting planet. And what's that look like? That looks like a pizza. A cheese pizza with the black olives and a little bit of tomato. And that's all sulfur. Where does the sulfur come from? Io is the closest in. It's about the size of the moon. From Jupiter's gravity field and some of the others, it gets squished back and forth, keeps it hot, and is one of the most volcanically active bodies anywhere in the solar system. In fact, when the probes went by, they saw active eruptions. That was quite a surprise when Voyager 1 passed Jupiter. And again, those colors, depending on the temperature of sulfur, it can be any of those colors. In 1994, we were in Eagle Butte, South Dakota. There was an asteroid broke apart and struck Jupiter. And those are some of the impacts. Now remember, Jupiter is about 11 times the diameter of the Earth, so that impact feature is about the size of the Earth. Wonder what would have happened if that had hit the Earth. My suspicion is you wouldn't be paying the next month's rent bill here at Friends Homes. Wouldn't be much of a, had that hit the Earth, yeah. So we are sort of sitting ducks with asteroids coming in and can plow into us periodically. And then the beautiful planet Saturn. And again, when we go to Klein Observatory, we should be able to get a nice view. Beautiful rings. When Galileo looked at it, he thought there were bumps on either side. His telescope wasn't good enough. And then they disappeared, and then they reappeared, and Galileo was quite confused by it. Took some later people to figure it out. Why? Well, because Saturn's axis is tilted. So we don't see the rings edge on, and because of the tilt, as Saturn goes around the sun, it takes about 20 or 30 years to go around the sun. I forget the number. Yeah, it's somewhere around that. But sometimes you see it from the bottom side, and then depending where it is in the orbit, you see it edge on. In fact, when it appears edge on, the rings appear to totally disappear through telescopes. And then you'll look down on the top side. Yeah, there can be aurora on Saturn as well. And take a look at the beautiful thing. You'll never see a view like this because it's a view from above, and you're looking down, you can see the shadow of the Saturn on the ring. And if you look carefully, there's kind of a strange feature. Here it is is a strange hexagon. The storm cloud systems from convection and so on have generated this hexagon formation. It appears to be linked to some very deep atmosphere phenomena. But it is there and has persisted, and that hexagon storm is probably at least the size of the Earth. Another very beautiful view looking at Saturn from out beyond, which we don't see because we're not out beyond. And looking back, the sun is blocked by Saturn itself, but the reflection off the rings illuminates a bit of the backside. The ring structure is very complex. Instead of being rings, it's actually many, many ringlets. The dark bands are spots where moons have gravitationally have pulled the material out of that region. So what are Saturn's largest moons? Titan is the second largest in the solar system. And that a probe has gone to Titan. What's it like on Titan? Very, very cold, but you might be able to swim in a lake. You might get caught in a rainstorm. There are rocks on the surface. Oh, but what's it like? Because Saturn is so far from the sun, it gets only about about 1% of the sunlight that we get. Very heavy cloud cover, so we never saw, but with some infrared probes and also a lander going down through, they found the lakes, and the lakes are probably lakes of methane and ethane. So if you get caught in the rainstorm, it's probably a methane or ethane rain. Fuel up your car tank with that fuel, it'd be great. And those rocks are probably frozen ices. Here are some of the other moons. Enceladus has some eruption. There's Dione. Iapetus is very strange. There's kind of like a walnut shell ridge, and the one side is very light, almost snow white. The back side is blacker than coal. So it's a very, very strange moon. And there's Mimas and Hyperion. This impact crater, had it been much larger, it would have knocked the moon apart. We move on to Uranus, and about as featureless. Now, there are some bodies, again, much smaller than Jupiter or Saturn, and much less massive. Uranus and Neptune are the icy planets. A lot of water, probably frozen ammonia, again, very cold. We know about Saturn as being the ring planet, but it turns out that all of the Jovian planets have rings. This is a ring around Uranus. And there are some features on it. Going out to Neptune, in a sense, the furthest planet in the solar system. And if somebody tells you to go fly a kite on Neptune, they're probably giving you a death wish, because some of the storms are the winds are so violent that you wouldn't be able to handle it. Dark blue spots, a number of features. This is a recent image taken by Webb, and the Webb image has shown the rings basically from the Earth's distance. Neptune's rings do show up. And here's some of the storms on Neptune. Cloud cover, again, a lot of methane and similar hydrocarbon gases in the atmosphere. Neptune's largest moon is Triton, almost a cantaloupe type surface, And there's something very strange about Triton. While it's smaller than our moon, all moons tend to go in the same orbital direction around the planet as the planet rotates. By the way, for Uranus, the axis, instead of being perpendicular to the orbital plane, is tipped almost into the plane. And what's strange about Triton, instead of going the proper way, it goes the opposite way. It is a retrograde motion, may have been captured from some other body. And these probably are some geysers, so there are a lot of strange things. So what about Pluto? Okay. Pluto has now been called a dwarf planet rather than a planet. And Pluto's orbit is very strange. It is so eccentric that Pluto is not always the most distant planet. Sometimes Pluto comes in closer than Neptune, but its eccentricity takes it further out. And a few years ago, the probe went by Pluto, and I think it was significant because it takes about 250 years, more or less, for Pluto to orbit the Sun. And is Pluto the same when it's close to the Sun as it is when it's far from the Sun? May not be. There's a lot of ice. This is probably predominantly rock. At the temperature of Pluto, water ice would be as hard as rock. And here's an exaggerated feature of that little region, sort of a heart-shaped region there. It does have a thin atmosphere. It's possible that when Pluto gets far from the Sun, it'll get so cold that the atmosphere will freeze out. So I think it was significant that the probe did go by, because we wouldn't have that chance for a couple centuries. So we now have a baseline to go from. Here's Pluto and its large moon Charon. How do we weigh planets, by the way? Well, did you ever do a square dance? If you grab your partner and swing? Okay, who moves most? The big one or the little one? The heavy one or the light one? It's the light one that does the most moving. If you have one body and orbit around the other, you can determine the mass of the bodies. And that's the way we weigh them. So here was the probe that left the Earth, and here we are. The Jupiter system is in there, Uranus, Neptune, and we get out to the orbit of Pluto, and Pluto's orbit is quite tipped, so it doesn't fit. Also, there's a lot of other bodies out beyond Pluto. There was, before the probe, that was the best one of the best images we had of Pluto and Charon. So are those 9 bodies the solar system? Well, not all, because there is some other material as well. There are the asteroids, particularly between Mars and Jupiter. There's a band of lots of asteroids. Ceres is the largest, and then beyond Pluto, Ultima Thule was, after the probe went by Pluto, they went past this small body. And you can see roughly where things are on that scale. There's a lot of asteroids between Mars and Jupiter, and there's also some that share Jupiter's orbit. Bennu is one that, by the way, the name came from a young man here in the Greensboro area, came up with that name. Some of the moons like Ida have the asteroids have little moons themselves. Here's Ida and its moon Dactyl. There's a number. And some of them you see are very strange shapes, like dog bones and so on. There are thousands of these asteroids. If you discover one, you may name it. The tradition is generally to name it after your sweetheart. I thought of finding one, but I didn't accomplish it. But anyway, there's still a lot more to be found. In addition, there are the comets. What are comets? Dirty snowballs. Mixture of water, carbon dioxide, ammonia, various ices. And the reason for the tail, as they come in close to the sun, they get warmed up and some of the material cooks off. And that's what this was, when Halley's Comet last came by, a probe was sent close enough to see what it looked like. Comet West was a beautiful one. Hale-Bopp was, frankly, the last good one that I think I've seen. Typically, I'd say there ought to be a decent one once every 10 years. So I think we're overdue for a nice comet. There is another one that's just been discovered recently. It may get bright enough that under a very dark sky you might be able to see it without a telescope or binoculars. Not here at friends' homes unless we shoot out all the lights. But anyway, as I said, I think we're overdue for a good comet. Now, why are they? The tails are split. There's a dust tail and the gas tail, and that's the reason for the split. In addition, there are the meteors, and we've just had the Perseid meteor shower. Under a very good condition, under dark sky, you will see lots of meteors. I've seen the Lyrid meteor shower once that I would say was a really neat shower. I probably counted a couple hundred meteors in a rather short time. That doesn't happen very often. But what happens? Well, those bright streaks are basically like basically grains of sand that are traveling through the Earth's atmosphere so rapidly that they heat up the atmosphere and make the atmosphere glow. And every now and then, if they come from comets, they're not very strong material. But every now and then, one will land, and right here I have 3 meteorites. So if you would like to handle a piece of space debris, come up and I'll let you hold it. Frankly, a meteorite this size would have made a beautiful streak through the sky. Frequently the meteorites come, rather than just a single one, it's a large body, frequently from an asteroid that breaks up, and there will be multiple meteorites land. And as I said, if you want to see and hold them, come up and I'll let you hold it. And occasionally a big one will land and kick out a lot of material, create a crater. Tim had the privilege to visit a big meteorite crater in Siberia and picked up a bunch of these rocks blackened from them. So if you want to learn more about that, talk to Tim. So those are some of the bodies of the solar system. There's a lot of material out there, and a lot more we still have to learn. So thank you, and are there any questions? Yes, Jan.
Could you explain quickly about the rings around Saturn?
Yeah.
How they...
Remember, the closer you get to a body, the faster you orbit. Now, suppose you have a fairly large object and it gets fairly close to the parent planet, the inside wants to go faster than the outer edge does. There's what's called the Roche limit, And if you get inside that, the forces from the different rotational velocities in effect get strong enough that they break the planet apart, and the body apart. And that's basically what has happened. Probably will happen with the moons of Mars sometime. Any other questions? Yes?
I heard that India sent up something that crashed on the ice part of the moon.
Yep.
Could you talk about that just a little bit?
It's kind of interesting because the United States, well, there was the race between the United States and Russia to get to the moon first. We beat the Russians, and unfortunately that dried up a lot of funds for science. Before that, there was a lot of funds for science, but because we beat them, the race was over. You don't keep playing the football game afterwards. Well, but anyway, a number of other countries have sent objects to the moon. The Russians have successfully landed some material. They tried to do it recently and failed, and India just succeeded, and they landed near the pole. One of the interesting things, while the moon doesn't have a significant atmosphere, there are craters on the moon that never get sunlight because of the depth near the poles. And there is evidence that there may be ice in some of those, and that would be significant. So that was probably part of the reason why India was trying to land, and they did successfully today, land their probe near the pole. It'll be interesting to see what information comes from that. I think, I expect that the United States is planning to return to the moon, and I suspect there may be some polar missions there as well. Other questions? Well, thank you very much, and next week we will look at a star from its birth to its death. Thank you.